Today I'm showing you Gitingest. It's an open source web application, CLI tool, and client library that converts Git repositories into LLM-friendly text files. This is an awesome example of a tool that's highly specialized to do one particular thing that's actually really helpful, and I'll show you why in this video. Now, in addition to just bringing your attention to this really interesting and helpful tool, the purpose of today's video is to have some fun playing around in the terminal with local language models and show you how Gitingest can help you with your workflow. I'm going to show a few use cases. So I'll quickly demonstrate how the web application works, and then we'll get into the terminal and install this thing and do some demonstrations. By the way, here on Zaz and Codes, I'm teaching AI engineering to data professionals. So if you're interested in learning, then you should subscribe to my email newsletter. I just send one email a week when I upload a new video, and I explain all the topics from that video so you can decide if you'd like to watch it. I also include an inspiring quote. So here's the web application, and we're going to turn any Git repository into a simple text digest. This is an increasingly important thing to do in order to feed LLM's context of our code base. I noticed this style, the front end is styled in something called neo-brutalism. Actually, my friend noticed this and he pointed it out to me. So if I look up neo-brutalism, I can sort of find this component library. And just bear with me for a second, you'll see where I'm going with this. But I thought I'd show you this because it's pretty cool. It's a pretty cool little style here. But I found the Git repository for that. I can open that up. And so let's ingest this code base into the tool. So I'm going to copy this URL, come back and just paste this in. And I'm going to click ingest. And you notice there's a few options here. I'll talk about these in just a second. But let's talk about the output here. So first we have a summary right here, and the summary says what our repository name is, and it says how many files we analyzed. So we analyzed 500 files like in just a couple seconds, really fast, right? And then the number of tokens, and look how large this is, 623,000 tokens. And that's going to be the size of this file down below, this file's content. Text file, which is the main output down here. We also have a directory structure, which is pretty cool. There's like a Git tree view. If I scroll down a little bit, I can show you what the sort of LLM-friendly file looks like. We have these bars and the file name and then some more bars. And this is how it's structured with this tool. And then everything below is assumed to be content, like the content of that file. So here's the README. And if I scroll down, we have some other files. These are other top level files in the project. So because this context is like so large, there's ways to like filter this down. So what I could do is say, I just want to include the source directory. Particular code, that might be what I want to do. So I'm going to click ingest again. And really we want this estimated tokens to be a lot lower. Okay, so it's still way too high for most models, although some models could handle this much content. But that helped us a little bit. And you can see now the directory structure indicates we're just filtering on the source code, like in here. Right, so that's how this tool works in a nutshell, but we're going to be using this in the command line. So let's get started on that part of the video. And I'll go to the GitHub repository for Gitingest, and we can start working from here. All right, so let's get started by installing this. So we can install this with pip, and I can say pip install Gitingest. However, I don't like using pip this way. I'd rather use a tool called pipx. So if I run that, we can see I've already installed it, but I can just make sure it's updated. So I'll just say pip upgrade. Okay, so it's already at the latest version. And let me explain this pipx tool. In order to get that, you can just say brew install pipx. And what it does is it installs like global tools in your system in an isolated Python environment. And the best way to understand that is just to like look at what it's done. So we just used it with pip with Gitingest. So if I ask which Gitingest, we can see where it is. It's in this file here. Let's have a look at that. Okay, so if I actually look at that file, check out what's happening. When I call Gitingest, it's pointing towards this file in my local bin, but this file itself is not actually a file. It's a symlink that actually points to here. And this was all done just with this one command, right? Pipx install Gitingest. And it's gone ahead and installed it into this pipx virtual environment area on my computer. And I really want to drive home what's going on here. So let me go into here. So this is where it's installed. The actual like executable itself is in this bin folder. It's going to be this, where is it? This Gitingest, this is the actual executable right here. But check out lib. So if I say ls lib, and then there's going to be this Python 3.13 site packages. And these are actually all of the dependencies which are needed in order to run git ingest. Right, so anyway, it's really easy to install, but once you have it, you can just have access to this git ingest tool like this. So if I ask for the help, it can tell me some of the different options, the different ways to use it. But basically, we're just gonna run git ingest on some URL. So the first thing I'm gonna show you is how to run this on local code. So I'm gonna go back a few folders here, and we're gonna go to Zazenbot 5000, and I'm gonna run it on this project. I've talked about this project in the past. I can show you just a little bit what's going on. So this is a Python project that I've talked about in a previous series of videos for my Discord bot. So let's run git ingest, and I'm just going to type dot to do the current directory. So it ran pretty much instantly. It analyzed 20 files and it output to digest.txt. So let's have a look at that. So it's starting by outputting the directory structure of my project, and I think the first step to using this tool is to look at this directory structure and make sure all of these files are what you want to include in here. So for example, I have this PyCache folder, but it doesn't look like there's any files in here. So I could just sort of check if PyCache is referenced. Okay, so it looks like there's none of those files in here. That's what I expect. That's good. But look at this, my credentials are in here. So I have these Google credentials.json file, and that's going to be included inside of here. In fact, I can't show you this or I'll leak my credentials to you. So I definitely don't want those in here, and I'm going to have to deal with that before I actually use this. But you can see otherwise it's pretty much what we expect. It's the same format like we saw from the web application, and we have all the files and the contents below. So before we, so the next step, what I'm going to do is remove this credentials. So you didn't see the credentials there, but they're in here. And if I look inside of that folder, there's this like hidden file. And this, by the way, is in my git ignore, but for whatever reason, it's not ignoring those credentials. So that's just definitely something to be aware of. And how we could do that is we could say .e, and I'm going to say credentials like this. So now it's written. You can actually see that it's 19 files. So it's gone ahead and removed that, which is exactly what we want, right? So now it's no longer in here, and yeah, there shouldn't be any leaked credentials in here. And that's really important, I think, right? Like we don't want to be showing our credentials to these language models and having these like in our context of it's just like, it's leaking private data. We shouldn't be doing that. So now let me show you how I might want to use this file with local command line tools with a local language model. And I'm just going to run the command for now, and then we'll talk about how you can actually set this up for yourself in just a second. So I'm going to run this whole digest file, and I'm going to feed it into a local language model running on Ollama called Gemma 3, and I'm going to use the 4 billion parameter model. And I'm just going to say, explain this project like I'm 5. So at this point, we're going to spin up this local model. So let me say NV top, and I want to just look at my GPU. So you can see it picking up, and my memory is going to increase as this model is getting loaded into my memory. And my GPU is picking up. So now my GPU is at 100% as this is getting processed, and we start spitting out our output. This is all running locally. I'm not paying for any of this. You have a really smart robot named Zazenbot. It's funny, it assumes my videos are about meditation because of the Zazen thing. This is kind of cool too. It's like giving all of my files names. This is like anthropomorphizing the files. Anyway, whatever. Wow, it's really going in here. What I'm going to do is put up on the screen the installation instructions so that you can run this type of thing for yourself. So the first thing you need to do is install Ollama. And you can do that with like a sort of drag and drop downloadable app for Mac, or there's a command line tool, like a command that you can run on Linux in order to install that. And then you'll need to pull the Gemma 3 model. I'm using the 4 billion parameter model, but I'm going to be using the 12 billion parameter as well in this video. Then the next requirement is the LLM command line tool. And then there's an extension for that called LLM Ollama. But this is really easy. Just they're kind of two commands that you need to run. And I have those on the screen as well. And at this point, I realized this thing is in an infinite loop of going between the teacher and the organizer. And actually, I've seen this 4 billion parameter Gemma model get into these infinite loops before. In my previous video, they got into an infinite loop on trying to count the number of L's in Lollapalooza, which is hard even for a human, although I've never got into an infinite loop on that task myself. So let's cancel this. So today, talking about Gitingest, we're looking at a lot of code on GitHub, and you know what you need for that is version control. So in my course, the AI Engineer Roadmap, I walk through everything that you need to know if in your journey to learn AI engineering, including Git. So I have this course on Git basics, and I've just added this feature on audio. So you can actually go ahead and listen to the lesson if you wanted to be like narrated to you. So I got Paul and Grace, a couple of voices you can choose from, and you could sort of check these out. But also, if you purchase the course, then you'll get access to like the full lesson Markdown files, and I have the full narration. So this one's like 7 minutes long, and the idea is like you could kind of listen to this on the go, you know, while you're in the car or something like that, and go ahead and check these off and work through the entire course. So if you want to check that out, it's on zazencodes.com. Okay, I'll let you get back to the video with Gitingest. So the next thing I want to show you is how to use this Gitingest on a remote repository. And we're going to be looking at some source code for the requests library. If you're not familiar with requests, I'd be pretty surprised, because this is the way that most people make web requests with Python, and I use this library all the time at work or in personal projects. It's like the GOAT, you could say. So let's have a look at this library with Gitingest. So now I'm working in like an empty project, and I'm just going to say Gitingest, and I'm just going to paste that requests GitHub link in here. Now, did you see how fast that was? It was like almost instantaneous, and it analyzed 117 files, but in those files, we got 2.6 million output tokens. So this resulting digest is going to be way too big. It's like 4 megabytes big. It's way too big to feed into a language model. If I open it, so what I want to do is I want to ignore all of this stuff, the README, the docs, all this stuff. I want to, again, just look at the source. So I'm just going to get all these Python files from the source. This is what I want in my digest. So how I would do that is I would type a -i flag for include, and I'm just going to say source like that. So now the context is definitely manageable. We have 42,000 tokens. This will fit in the input for Claude or for OpenAI, definitely for Gemini. And we've analyzed 18 files, only 18 files now. And this is our digest. So it's just these Python files. And this is like perfect for certain types of tasks that we might want to do with language models. Okay, get out of here. Okay, so I've been messing around a little bit here. Let me show you this sort of pattern that I've found and what I'm doing. So the first thing I want to do is print out the contents of this digest and pipe it into the LLM tool. And I want to run it on my Gemma 3 model, and I'm going to do the 12 billion parameter model because it's a bit smarter. And now I want to ask it some question. But instead of having to type this every single time, I want to make an alias for this. So I'm going to call it DQ, and I'm going to just put this into an alias. And now when I type DQ, I can just do that, and then I can type my prompt in here. And then, so for example, I could say, you know, what is this? Just do simply, what is this? And now I'm monitoring my usage down here. And I should already have this model, this Gemma 3 loaded into memory, because I've been playing around just for the last few minutes, which I cut out for you guys. But the point is, this is already loaded into memory, so it's just starting on processing this task. It's feeding all of this information in, all of this digest in, as well as my prompt, what is this? And now we're getting our output. So this was all real time. There were no cuts. So you can see how long it takes this Gemma 3 12 billion model to just like start talking to you. This is like just the reality of using local models, especially good ones. Like the 12 billion model from Gemma, it's going to give you some decent output, some actual interesting stuff is going to come out of here. You can also see my usage here, like we're going at 100%, but I still have tons of memory available. Right, okay, so let's cut this off and clear this. Like, what are the most important files? The init file, the entry point of the entire library. I'm just trying to demonstrate basically with these questions that like this digest is providing the full context of like the code that we wanted to understand. It's also done a pretty good job at the hierarchy. So we have like utilities at the end and exceptions is at the end. Like these are definitely less important aspects of the application. Okay, so now I have a real test for this. Let's try to ask for a feature. Extend this application to support JavaScript rendering. So if you've ever done web crawling or making web requests, you'll know that a library like requests doesn't actually render the JavaScript on the page. It's going to return the response from the server. If you're using Chrome and stuff, every time you request a web page, your browser starts rendering all of the JavaScript, but a requests library is not going to do that. There's ways of doing that, for example, with Selenium. Playwright is a newer and arguably improved alternative to Selenium. Right, so now we're getting into like how we would want to do this. So if so Gemma 3 is trying to integrate Playwright. That's actually a smart idea rather than just like going ahead and running, writing like an actual JavaScript rendering engine into requests. Of course, like requests would probably never want to do this, but it's kind of interesting that given the context, it's able to like start building this out for us. I can hear my computer, by the way. Yeah, it's working pretty hard at this point. Or it's not so much that it's working hard, it's been working hard for a long time. And because of that, my MacBook has detected like that it needs to cool down. So it's turned the fans on. Right, so the plan is I'm gonna wait for this to finish rendering and I'm gonna ask a follow-up question. And I wanted to demonstrate to you how you would do that with this like LLM setup. And what I would do is I would just type LLM-C, and this indicates that I wanna continue the previous conversation. And so I can ask a follow-up question on all of this. And what I'm gonna say is, what files would you need to edit for this feature, ? So rather than any of the details, I'm not actually interested in like if this is a good feature or not, but I just wanted to demonstrate that this is working in terms of the context. Let me just sort of pause it. Integrate the JavaScript rendering feature. So clearly it does have the context of the previous call. And so this -c flag, that's how you would go ahead and do that. So what's key though is you have to let it finish. If I was to cut this off right now, it would screw up the whole like process of being able to continue the conversation. So that's one thing to keep in mind when you're using like the local model setup, how we're doing things. You got to let it play out here. I do have to say though, I'm a little disappointed, like this file structure summary doesn't actually seem to be using the same file structure. So actually what I could do is if I look at the head of the digest, I need a little bit more than that. Maybe the first 30 lines. Okay, so what if I put this in and then I put that into my LLM and I was just like, hey, no, integrate it into this file structure. Let's see if it can handle that. Yeah, that's cool. So now it's doing more what I want it to do. So right here, we're like request.renderers. So we're going to put it in here and I'm going to create a new folder called renderers. And then this is in like a render. That's pretty cool. That's how you might want to, clearly this is like a flat, like there's no hierarchical structure in this request library, which is pretty cool, pretty minimal. And now it's actually like breaking down I wonder if this would work. Actually, probably this would actually be a decent shot at this feature. All right, so the last thing I want to show you is the SDK, and I want to show you the Python library. And you can use it like this. We can import it and ask questions and get data inside of Python. And I'm going to just show you the synchronous usage just real fast. It's really simple, but I think I'll show you something that you're going to like. So remember we were like asking where this was. So git ingest, and it was in here. But then when I actually looked at that, like if I do ls and then I say which git ingest, it was actually symlinked in here. So if I look in this, but just inside of the bin, I have this Python inside of this bin. So what I can do is open up this Python. So I don't want to ls it, I want to just execute this. And what we're going to do is this will take us into the Python interpreter that has the right environment to use the git ingest library. What am I talking about? So I can say import git ingest, and if I spell it right, so now I could say from git ingest, I'm going to import ingest, And I can run this, and it's going to output 3 different things. So it's going to give me a summary, it's going to give me a tree and content, and then if I can just paste in anything I want. So here I'm going to use one of mine from YouTube. This has all my like first year source code stuff for all my videos, and I can look at the summary. So we were looking at, okay, we analyzed 250 files, we have 2 million tokens of content in here, and it would be better if I printed this. So I can print the tree, and here's all of my, like, this is what the source code looks like. You have all my different demonstrations for all these like different videos that I made. And then the interesting part is the content. So I can print that as well. And let's just print the first like 100 lines. It's like nothing, 1,000 lines. So here's all my stuff. And of course we could do all sorts of fun LLM stuff. For example, like we could throw an MCP server around this, and then that would just like give language models the ability to use this themselves. And by the way, if you didn't like that, how I sort of like opened it up here, I can show you again another way to do it. What we could just do is type Python venv like this, and just go ahead and create a virtual environment. Then I could do it like source venv bin activate. And now if I say I go into this Python, this is inside of my virtual environment, like right here, I have it like activated. And I could try and import it, right? So I could say from Gitingest import ingest, and it's not going to let me do that. This doesn't exist. So I could install it, and I would just say pip install Gitingest. So it goes in and installs that. I can open Python, and now I'm able to do that. Let's do season 2 this time. Right, and so this is all, let me just show you this. This is all the same thing that it was working before, but that's just how you would set it up, like if you actually wanted to use it in a project, right? You just go ahead and install it. I hope you learned a lot from this video, or at least like 1 or 2 things that you can go ahead and start using in your work in the terminal. And if you did get this far, I'd appreciate it if you give me a like and consider subscribing. These actions help me out a lot on YouTube in order to grow my channel and continue making content like this. And speaking of related content, I have 2 videos that I'm gonna link to you. There's one that's more about using Ollama in the command line, and then another tool over here that's more about using this LLM tool with ChatGPT, or like cloud-based models. So you can pick your path if you have some time and keep learning about terminal stuff. Thank you for watching, and namaste.